All right, the intermediate value theorem. Now, because the word theorem is in there and the word value, this thing's a little scary. And to be honest with you, it's annoying and it's super mathy, but on the bright side, you probably won't see it on the test, except for a very specific type of question, but it really depends on your teacher. Like a lot of teachers won't ask questions at all, and then the ones that do, they sort of usually have a pet type of problem. So you really just want to ask your teacher ahead of time, hey, what kind of questions could you ask about the intermediate value theorem? If you look at quizzes or like any review sheets or your homework, figure out which types of problems are asked about this, because there's only going to be one or two, that could be asked even. So I'll work a couple here, but again, this is like one of those really fuzzy things. It's almost like they put it in the book and they want you to memorize some theorem and understand the foundations of calculus, which I guess there's something really important about this thing, the calculus, if you want to be Goodwill Hunting or something. But aside from that, it's pretty useless to your typical calculus student. So don't worry your head too much about it. We're just going to go over the basics here. Now, I'm not going to give you the actual wording of the theorem because it's pointless to even show. It's so complicated and confusing looking that I find students just have no idea what the heck it says, even if I try and explain it. So what I'll just tell you is what's roughly going on. What they're saying is that to get from point A to point B with a continuous function, now the most important thing about these and the kind of question you might get is, it has to be a continuous function. What they're saying is if you want to draw, connect point A and point B with a continuous function, there's no way to get there without crossing the x-axis. And that's the most common type of question, is they'll say, well, hey, prove to me that this function must have a 0 between 1 and 2. And you'd be like, well, gosh, if I plug in 1 and I get f of 1, or in this, in the case of this drawing, I plug in negative 1, to the function I get a positive number, I get 3. And I plug in 2, and I get a negative number. Doesn't it make sense that in order to get from this point to this point down here with a smooth line, I must cross the x-axis at some point? I don't know where it is. That's what's dumb about this theorem. It doesn't tell you where it crosses the x-axis. It just narrows it down to somewhere between here and here, because those are the x-coordinates of A and B. So that's why it's useless. The only thing it helps you out with is if you're in pre-calculus and doing a bunch of doing that section where you have to like do synthetic division and polynomial long division and try and figure out all the zeros and blah, blah, blah. If you had a laundry list of like 20 roots you were about to try with synthetic division, and you could narrow it down to just a couple of them using this technique, good for you. But then again, students are already doing that using their graphing calculators. You can kind of narrow it down and try and see where you think the zeros are and try those things with synthetic division first. So point is, once again, this theorem's pretty much useless because it doesn't give you a root. It just tells you where a root might be. And there might be more than one. So even though I have to cross the x-axis once to get from A to B, well, boy, couldn't I just cross it 1, 2, 3 times? Or couldn't I cross it once and then just glance off the bottom and have a double root right there? That's why this thing is so useless. It doesn't help you at all, practically. So anyway, so it's super annoying. All right, so let's go back up for a second. So here's a point, again, this time instead of A and B, I'm giving you specific points, negative 3 comma 4, 4 comma 1. All the intermediate value theorem says, now in this case it's totally useless, right? Because the only thing you're ever trying to do is find zeros or like x-intercepts of a function. This doesn't tell you what the x-intercepts are. All this tells you, because in this case the 2 points are both above the x-axis. So the intermediate value theorem is truly of no use. All it's saying is, hey, since we're going from a y value of 4 to a y value of 1, at some point we're going to cross everything in between. So at some point on this graph we're going to get to y equals 2. And at some point we're going to get to y equals 3. And at some point we're going to get to y equals 3.5. Now it turns out this one actually goes beyond 4. And going from 4 to 1, this thing actually swoops all the way up to like 4.5. But the intermediate value theorem won't tell you that because, again, it's useless. All it does is like, don't get me started on the intermediate value theorem, man. What a pointless mess. All right. And I'm sure mathematicians, if you're majoring in math, bravo. I'm sure that the intermediate value theorem is like the basis of a higher order derivative something or discrete math or something, but I don't know about those things. All I know is the intermediate value theorem is totally useless in calculus class. All right, now just for a second, in case you're one of the few students who has to know the complete wording of the theorem and everything, I'm just going to give you a slightly mathy thing for a second. So if you're in an easier class or like calculus for business majors, feel free to tune out and stop the video right now. If f is continuous on AB is how the thing starts. So a function that's continuous, that's the key word. That means that we're going to not lift our pens between the 2 points. And it's got to be continuous on the interval AB. So the interval AB, just to remind you, means all the numbers between A and B. And since we're talking about a function, what they're really saying is, hey, all the x's between A and B, including A and B, if f is continuous on that range, then they'll say something like, for there is a point between A and B. So somewhere in this x, there's going to be a point for which the y value equals something in between fa and fb. All right, that's as mathy as I'm going to get. I just want to remind you what intervals are. All right, last thing is, this is just a representation of what could be on your graph and calculator screen. I just want to point out that when you're looking for roots of functions, and usually you do this in pre-calculus, not calculus, but if you're looking for zeros, you can take all the factors of this and divide it by all the factors of this, and that'll give you your p over q or whatever. It'll give you a laundry list of possible zeros to try, in synthetic division and stuff, to find all the zeros of this function and blah, blah, blah. You can, it's highly recommended that if you have a graphing calculator and you're allowed to use it on the test, that out of that giant laundry list, like in this case we have plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, out of this laundry list, we want to narrow it down by looking at the graph, and that's kind of what the intermediate value theorem is actually kind of helpful with, although we're using a graphing calculator instead of the theorem. But as you can see, this graph looks like it crosses right there, right? It looks like x equals 3 is probably a 0. So that means that the first thing we do in synthetic division is try putting in a 3, synthetically divide that into 1, negative 3, negative 2, 6. And we'll get whatever, and it turns out if you do this, x minus 3 comes out of that 3, and then you'll have x squared minus 2. And then you could solve for the other two roots, and they'll end up being 2 and negative root 2. So this point right here is positive root 2, and this point right here is negative root 2. Whatever. Just wanted to point out that that's kind of a bastardization of what maybe you could possibly use the intermediate value theorem for if your teacher was really reaching. If it's a multiple choice question, or if it's on the AP test or something, you might get in the wordy mathematics version of things like, you want to remember the function has to be continuous. So if they don't say the function continuous, then their intermediate value theorem does not apply. Yeah, that kind of thing. If the number you're looking at is not between the two numbers, like if they gave you, a point here and a point here, that doesn't tell you anything about the function over here. It only, it only applies to the interval AB. So anything between point A and point B, if point C is way out here or way out here, again, intermediate value theorem tells you nothing. So it's got to be continuous, and it only applies to stuff in that interval between the 2 points you're looking at. Everything else, you should ask your teacher.